Okay, so yesterday we learned about conducting tests about a population mean when we had one sample. The same thing is happening today. We have one sample, except for we're going to be dealing with a sample that we took that sample and we conducted an experiment using a matched pairs design. So this is a very specific type of problem in where we're talking about matched pairs. If you remember back from chapter 4, matched pairs was when you take the same group of people or two very similar groups and you match them up. So in this example, we're talking about the express lane at the grocery store versus the regular lane, and which one is faster. And so what they're doing is somewhat like a matched pairs design in that they have two people going to the grocery store buying the same number of items, and they're going to randomly either go to the express or regular line, but it's the same two people. So that it's Libby and Catherine. And so what we're going to assume is that on that specific day, let's say it's Monday at 8:15 a.m., they both get into the same line, the express lane or regular lane. How long does it take them? And then they do this again at another random time, like Tuesday at 12:27 p.m. They have their items, they both go into these separate lines in some kind of random order. So it's an experiment in which we're thinking about these as being matched data. So when you look at this 337 seconds and 342 seconds, that was the same day, same exact time. So the store should have been the same as far as busyness goes, right? And then what we can do is say that those are actually representing a matched pair. So what we're going to do is create one list of numbers from this data and conduct a test using the difference in the means. The question is the express lane faster? So what we're going to do eventually is subtract these two numbers because I want to know, does it take a longer amount of time in the express lane? Oh, actually, well, is it a less time in the express lane than in the regular lane? Yes, sir. Yes. Yep. So what we're going to do is we're going to take this regular time and then subtract the express time. So we're going to do regular minus express. Now, we could do it the other way, but it just makes more sense to do it in this direction. And when we do that, we're going to come up with a brand new list of numbers. Who doesn't want to have to do that all by hand? I don't want to. Okay? So what I'm going to do is put these in my calculator in the lists and tell my calculator to subtract to get a new list of numbers. And then from there, the entire test is exactly like what we did before because we're going to have one list of numbers. We're going to calculate the mean and the standard deviation from that list. We're also going to check to see if it's approximately normal, meaning there's no outliers, because we definitely don't have 30 numbers in our data set, right? And then we're going to go on and calculate a t-statistic and find a p-value. In the process, at some point, we have to identify our hypotheses, all right? I kind of summarized this, I think, enough. They've got 15 times during the week that they go to the store. They're buying actually only one item, and they're randomly choosing express or regular lane at the same time to get these numbers. That's where it came from. So our problem is, how do I carry out a test to see if there's convincing or significant evidence that the express lane is faster? The key is that these are paired data. For right now, this doesn't matter to you because we haven't learned about anything else, but come chapter 10, we're going to be looking at two separate samples and calculating a difference between two separate samples, and that's different than what we're doing here. Here, we're taking technically a couple of sets of numbers, and we're going to create one sample called the difference. And that's how this chapter, or this section, part of this section is different than what's coming up later. But since the data is paired, we will consider the difference in times, like Aaron said, in parentheses, regular minus express. In this case, if I do the subtraction, regular minus express, and I get a positive number, what does that actually mean? It means I spent more time in the regular lane, so which lane was faster? Express lane. So in this case, a positive difference means that the express lane was faster. So a term that you just have to recognize, remember the term difference means you're subtracting. So from now on, we're going to start to talk about the mean difference. in these values. And so when we do first the state, when we test our hypotheses, we're going to make our hypotheses about the mean difference. So mu sub d, new terminology kind of, or new notation, versus h sub a, mu sub d, something. And so if there was no difference at all between these times, what would we see for the mean of the differences? So when I find all these differences, add them up, divide by how many there are, what number would it be if they were exactly the same times? 0. Because like 300 minutes and 300 minutes, or seconds, I think it was, 200 seconds, 200 seconds, 100 seconds, 100 seconds. Whenever I subtract, I would have, if these were all exactly the same, I'd have a mean difference of 0. Or at least the same enough that it canceled out, so the mean was 0. So that's my null hypothesis, is that the mean difference is 0. My alternative hypothesis, what I'm trying to test, is do I have significant evidence that the express lane is faster? That means a positive difference. So the difference has to be greater than 0, the way that I wrote this question. Now, Aaron chose to do regular minus express. What if we had done express minus regular? Then we would be looking for a negative difference. And so this alternate hypothesis would be less than 0. And then just make sure you define your parameters. So mu sub d is equal to regular time minus express time, express lane time. And we could put more words there, like that it takes to buy one item at this grocery store. But we start to get a little lazy as we conduct more and more tests. Oh, and I wrote that down already. Never mind. It's right here. The true mean difference, regular minus express in time, required to purchase an item at the supermarket. So what we're going to do first, I actually have it listed just above here, is put the lists in our calculator. If you want to do this with me, you can, or you can just watch and follow along. But I put these lists, because I already put these lists in my calculator. I went to Stat, Edit, and you'll see in list 1, I put whatever was on the left, the regular lane times. In list 2 was the express. Is that the right order from your paper? Okay. And then what I'm going to do is make list 3 do the calculation for me. So when I'm in list 3, I'm going to tell it to do regular minus express, right? So list 1, or list 2, list 2. List 2 minus list 1. That's what happens when you don't have your paper in front of you. Hit enter, and you can see the differences here. So for the first one, 5, so express lane was faster by 5 seconds. 246, this one the express lane was faster by 246 seconds. In the third one, actually the express lane took longer by 46 seconds. Can you see what this means? So these numbers in list 3 are actually the data set we're looking at. This is our sample. What we want to do with this sample is calculate the statistics on that sample and also look for outliers and things like that. So I'm going to do the outlier check first. I'm going to go to stat plot, turn my plot on, and just remember that I want to look for outliers, so I'm going to choose the box plot with outliers, and I'm going to make it look at list 3, not list 1. And then hit zoom 9 for graphing it. So you can see no outliers, which is good. There might be some skewing, but we have like 15 values, so we're probably okay as long as there's no outliers. So that's part of checking our conditions. And then let's go to stat, calculate one variable stats. You do have to tell your calculator to use list 3. So I'm going to go second 3, list 3. And can I have someone jot down the important numbers here? I want the mean, 42.67. And the standard deviation, 84.02.